Hello, welcome to the Screencast Lecture Series. Today is going to be energy transfer in the atmosphere, radiation. Radiation is heat transferred in the form of rays or waves. One of the main things to know about radiation heat transfer is that there is no need for a medium. Now, this is a picture of what's called a radiator. Now, you don't see these very often anymore, but maybe if you've been in an old apartment building or an old house, this could be part of their heating system, and it is called a radiator. There's no fans like on a forced air furnace, things like that. The heat is transferred through water, through hot water, through the pipes, and then the heat energy radiates throughout the room. Here's a more modern version of this. Here you see a radiant heating system, and they're putting it in the foundation of the house. So this would be actually underneath the floor, which would be pretty neat. And you can run hot fluids through there, and it will keep your house nice and warm without having different hot spots in your house. So like if you have a furnace, you probably notice maybe some parts of the room might be hotter than others, especially the ones near the heating vent, but this would avoid that problem. You can see what I'm talking about, where the heating, radiant heat is going to keep the room relatively consistent versus what most people have, like myself, where we have forced heat and the air blows out of the heating duct. It's much warmer over here, and by the time the air gets over to the other side of the room, it may not be quite as hot. Putting all three of the heat transfer types together. So if you have a fireplace and the fire is burning, and we did a demo like this in class, the fire is burning, the hot air is going to rise, and we know that that is convection. So the hot air rises up the chimney, and since their air is leaving this area, the air has got to come from somewhere. So some of the air is going to come from the room, and it's going to rush into the fireplace, and that's going to heat up, and it's going to rise up. And the fireplace is touching the part of the house. Here it is touching the floor, so the floor around the fireplace should get warm. The heat's going to go conduct through it, and you're also going to feel radiation. So that's why if you're sitting in front of the fire, you can feel that nice heat radiating towards you. Check out this diagram. This will definitely help you on the worksheet assignment that you have. Here's a question for you. Now think about the sun. Now the sun is releasing heat energy. How does that heat energy get to us here on Earth? Well, choose one of the following, either conduction, convection, or radiation. Radiation is going to be the correct answer, and probably the easiest way to explain why that's the case is to explain why conduction or convection is not going to be a good choice. First of all, it's not going to be conduction, since to have conduction, the objects must be touching. So the Earth and the Sun are not in contact. If that was the case, that'd be very bad news. And then it's not going to be convection. Convection requires a fluid medium. And as you probably know, that the space between the Sun and the Earth is mostly empty. It's mostly vacuum. So there is no fluid medium in space. So the convection could not carry energy from the sun to the earth. Therefore, it must be radiation, which travels heat energy through waves and does not require a medium. That's the key. Here are some review questions. What I want you to do on these diagrams is to think about what heat energy transfer is being shown in these diagrams. You may pause it and give yourself time to think if you need to. Otherwise, moving on to the answer. Yes, convection. So the warm air is going to move up to the ceiling. As you know, hot air is going to float, or hot air is going to rise. So what some people will do is they'll turn a ceiling fan on, even in the winter. I actually do this. I have ceiling fans in my home. So in the winter, what I do is we'll turn the ceiling fans on, and we'll have the air blow this direction, and it will take the warm air that's up on top of the ceiling and move it to the sides of the room, so to get it to circulate around and to move the hot air better throughout the room. And then in the summer, you flip the blades around and have the air blows straight down, so you get that nice cooling effect with the fan blowing on you. Versus in the winter, you don't really want to feel the fan blowing on you, so you have the fan blowing up towards the ceiling. Again, you may pause it. Answer is radiation. The fire is not touching them. That's a good thing. The convection is going to make the heat go up the chimney. And if this is actually an airtight wood stove, the convection, the air is not going to come in from the fireplace into the room. It's just going to be radiant heat radiating off of the airtight wood stove. Answers coming up. Of course, conduction. He is touching the hot metal. The hot metal is touching the fire, and the heat is going to conduct through the metal and burn his hand. Okay, this review goes back a little bit further. What is the total amount of incoming solar radiation that is absorbed? Pause it if you want. Answer coming up. 65%. Heat flows from what? From blank temperatures to blank temperatures. High temperatures to low temperatures. Heat transfer through direct contact or touch is called conduction. Which energy transfer does not require a medium? Radiation. What heat energy transfer do we see in action here? Well, there is a chair on fire, and that heat and that smoke is going to go in what direction? Correct, it's going to move up, and that hot air is going to be towards the top of the ceiling. That's why you will see firefighters crawling on the floor. Also, it's why if you are ever in a situation where you need to escape a building that is on fire, they say to stay low and go. You want to stay low on the floor because the heat is going to be up here. Okay, so the heat is going up here and spreading out here. This is showing cooler air from outside of the room rushing in to take the place of the warmer air. That's going to get heated up, and the cycle is just going to go like this. Here's a demo of a burning room, and you can see how much darker it is up here. All that smoke and other unburned fuel is up here. Significantly hotter up in this area. Being in fires, I tell you, I mean, staying near the floor, it is significantly cooler. I mean, it's not cool. I mean, it's still very hot, but I mean, you got your fire protection gear, and that's going to protect you, but you don't want to be standing up into this. That is not good. Okay, take a look at this. You can clearly see the flames rising. That is, of course, convection. You start seeing some layering. You can see how it's getting darker up near the top. That smoke, that unburned fuel, and the heat is much, much higher up on the top. You might even see some ghosting. You can see some flames up in that smoke. And this is a dried Christmas tree, and boy, it burned fast. Now this next scene shows a cigarette that was left on a sofa, and the tape is sped up a little bit, but you can see the counter on the bottom left, and you can start again to see the flames growing. You can see the smoke rising. You can see that the heat is going to go up due to convection. As the time goes by, you can start seeing that if the top of the ceiling is getting much more difficult to see, that smoke accumulation is happening. This is why you want to stay close to the floor. Okay, the layering again, those hot gases up on top. Those sofas and the artificial materials in the sofa, they burn extremely hot. Now this is a view from outside the room. You'll start to see the flashover right there. That is definitely not a place where you want to be standing. And here come our heroes to put out the fire. Well, thanks for joining us. I hope you enjoyed it. I know it was brief. There wasn't a whole lot to write, but that's okay. We'll catch you next time. See ya.